Hello and welcome to KISS Math. In this video, we will cover what to do if your equation contains absolute value expressions. Everything you learned about equations so far still applies, but there are a few things you have to do differently. So here are the steps for solving equations from the previous video, but I've modified them for absolute value equations. This time around, instead of isolating a variable, we have to try and isolate the entire absolute value expression. Once you do that, you'll make two equations, one for the positive answer and one for the negative answer. Allow me to demonstrate. So here's our first example. We have an absolute value, 7x plus 5 equals 9. So everything that's in the absolute value is already isolated to one side. So we don't have to do anything further here. All we need to do is create two equations at this point. So the way you do that is you just take this 7x plus 5, you write that again, this time without the absolute value symbols, and you set that equal to whatever is here on this right side. So that's easy. But the second equation you have to make, you do the same thing, 7x plus 5, but this time on the right side, you have to make the entire right side negative. So here we just have a 9, so that just becomes negative 9. So now you have two equations, and you just have to solve for x in the same way that we did before for each equation. So if we do that, on this side we have 7x equals, I'm going to move the 5 over, which gives me 4. Solve for x, that gives me x equals 4 over 7. And I'm going to keep this here and call that a potential solution. And the reason for that is sometimes with absolute values, not every solution that you find works out. Some of them are not valid, but we'll check that later. On this side, we have 7x equals, and if I move the 5 over, this will become negative 14. And then x equals negative 14 over 7, which is just negative 2. So we have two potential solutions here. The reason for that is think of something very simple, like the absolute value of x equals 2. Well, in this case, x could either be a positive 2 or a negative 2, because this absolute value just turns everything positive, right? So in the same way, everything inside this absolute value here, this 7x plus 5, this can either equal 9 or negative 9, which is why we made our two separate equations here in order to find both answers. And just like before, the next step is to check them to make sure they make sense in the original equation. So let's do that. The original equation's here, and I will plug in, let's do the 4 over 7 first. So we have absolute value of 7 times 4 over 7 plus 5 equals 9. And these 7's will cancel out, so you'll just get absolute value of 4 plus 5 equals 9. And the absolute value of 9 is just 9, so that answer is good. How about on this side? We have absolute value of 7 times negative 2, because that's this answer over here, plus 5, and that should equal 9. So we would have negative 14 plus 5, which is the same as negative 9 absolute value. And the absolute value of negative 9 is positive 9. So both of these answers check out. So we will have two solutions to this equation. X equals 4 over 7 and x equals negative 2. Example 2. So this one's a little bit more complicated because we have some more numbers outside of the absolute value. But the whole point of this, if you recall, is we have to try and isolate just the absolute value expression by itself. So let's go ahead and do that. I'm going to move off the 5 and move that to the other side and then divide by 4. So we'll have 4 times absolute value 3x minus 2 equals 33 minus 5 is 28. Then I get rid of this 4 by dividing it off. I'll get absolute value of 3x minus 2 equals 7. So we've successfully isolated the absolute value. This negative 2 stays over here because it's still inside the absolute value here. And so at this point, we'll make our 2 separate equations. The first one's always easy. You just remove the absolute value, and you set that equal to 7, like we had. And then the other equation, you will have 3x minus 2, and you set the right side to negative 7. So at this point, you solve both of these like normal equations. We got rid of the absolute value symbols because we split them into 2 separate equations. So let's go ahead and do the left side here first. I'm going to move this negative 2 over, so I'll get 3x equals 9. And then divide off the 3, which will give me 9 over 3, which is 3. Over here, we have 3x equals negative 7 plus 2 is negative 5. And then if I divide off the 3, I'll get x equals negative 5/3. So here are the 2 potential solutions to this equation. And if I go back up here, what I need to do is check both of these to make sure they're valid. So I'll substitute in 3 first and see what happens here. So 4 times absolute value, 3 times x equals 3, minus 2, plus 5 equals 33, and then we just evaluate. So 4 times absolute value of 9 minus 2 is 7, 5 is 33. We have a 28, 4 times absolute value of 7, plus 5 is 33. So that answer is good. How about the other one? So we'll have 4 times absolute value of 3 times negative 5/3 minus 2 plus 5, and that should equal 33. Now if I look at this fraction, these 3's will cancel out, and I'm left with a negative 5 minus 2. And we will have 4 times absolute value of negative 7 plus 5. And now the absolute value of negative 7 is just 7, positive. So 4 times that would be 28 again, plus 5, and that equals 33. So both of these answers are good. And this will have 2 solutions here. Example 3. So our absolute value expression is already isolated, so this one seems pretty simple. So let's make our 2 equations here. We'll have x plus 3 equals negative 4, and then we'll also have x plus 3 equals negative 4, which that equals 4, right? Okay, so this one will solve. X equals negative 7. That's a potential solution. And then over here, we had x plus 3 equals 4, right? So x would just equal 1. Now, if we plug these back in, and I'll do the -7 first, we would get absolute value of -7 plus 3 equals -4. And that would be absolute value. -7 plus 3 is -4 equals -4. Now, if I actually evaluate that, this would become +4 equals -4. So you see this answer, this x equals -7 is not a solution. It's not valid because when we plug it back in, it gives us an answer that doesn't make sense. So how about this one over here, x equals 1? So if I plug that back in, I would have absolute value of 1 plus 3 equals -4. And that would be absolute value of 4. And the absolute value of 4 is just 4, right? So 4 equals -4. Again, this one doesn't make sense. So this answer is out. So for this equation, you have no solution. So that's what you would write as your answer right here, no solution. But the reason for that is if you actually look at what the equation is telling you, it says you have some value plus 3 in the absolute value. Well, no matter what number you put in here, this absolute value is going to make that positive. And then on the other side is a -4. Well, there's nothing that you can do to make this left side negative. So that's the reason why this equation doesn't make sense and you end up with no solutions. Example 4. So again, we've already isolated our absolute value, so we can just straight write our two equations. 2x minus 3 equals 13 minus 3x. And then our other equation, 2x minus 3. Now this time, the other side of the equation is a little bit more complicated, but the entire equation for that side of the equation has to be multiplied by a negative sign. So I'm going to write that like this. Okay, so let's solve this one first. So I'm going to collect like terms. So I see this -3x, move it over here. That'll give me 5x. And then this -3 will have to go on the other side. That gives me 16. So x equals 16 over 5. And then over here, 2x minus 3, I'm going to simplify this guy first by distributing the negative sign. So that gives me -13 plus 3x. Now if I collect like terms, I'll subtract this -3x, so that will give me -1x. And then move the -3, that gives me -10. So x equals +10 if I divide off the negative sign. So here are my two potential solutions, and I'll check each of them here. So absolute value, 2 times 16 over 5, 3, equals 13 minus 3, 16 over 5. So if I evaluate this, I will get absolute value. 2 times 16 is 32 over 5 minus 15 over 5 is the same as 3 equals 13 minus 3 times 16 is 48 over 5. So this will be 17 over 5 and 13 is the same as 65 over 5. minus 48 over 5. And the absolute value of this is just 17 over 5. And 65 minus 48 is 17. 5, and so, yep, this answer checks out. And then over here, I had x equals 10, so let's plug that one in. So we have absolute value of 2 times 10 minus 3. And that needs to equal 13 minus 3 times 10. So, evaluate that. We have 2 times 10 is 20 minus 3 equals 13 minus 30. And so this will just be absolute value of 17 equals 13 minus 30 is negative 17. Absolute value of 17 is just 17 equals negative 17. And I'm so sorry, but this answer will not work in the original equation. So this is not a solution. Your only solution here is x equals 16 over 5. So for absolute value, it is very important to check your answers. All right, look at this crazy guy. So this one looks pretty complicated, but I know I'm going to have to isolate this absolute value, right? So if I do that, this 43 over 5, well, this is a pretty big number. I know that 40 over 5 is 8, so eventually I'm going to have to move this over, right? So if I do that, I will have something like 8 point something. And this will be a negative number, right? So just by looking at this guy, I'll have an absolute value of something, which is always positive, equal to something negative. And I know that's not ever going to be possible no matter what I put into x. So simply, the answer to this equation is no solution. So just watch out for something like that. Example 6. So this one has two absolute value expressions, but we can solve this in the same way. We can say that this x plus 3 over here has been isolated, or we can say that this x minus 12 has been isolated. It'll actually give the same answers. So let's do this one first, this x plus 3, and we're going to write two equations for it. So x plus 3 equals x minus 12, and x plus 3 equals negative x minus 12. So we do that, and we'll get x minus x if we move that over, so that's 0x plus 3 equals negative 12. Well, 0x is just 0. So you get 3 equals negative 12. So that doesn't make sense. So this solution's out. On this side, we have x plus 3 equals negative x plus 12 because I distributed this negative sign. If I move this negative x over here, that gives me 2x. Move the 3 over here, I'll get 9. So x equals 9 over 2. Now let's plug this solution back into the original. So we have absolute value 9 halves plus 3 is the same as 6 halves. And that must equal absolute value of 9 halves minus, and 12 is the same as 24 over 2. And if we evaluate this, we'll get 9 plus 6 is 15 halves equals 9 minus 24, that is negative 15 over 2. And absolute value of 15 halves is just 15 over 2. and absolute value of negative 15 over 2 is just positive 15 over 2. So that answer makes sense, and this is a solution. Okay, but what if we went the other way? So here's our original problem, right? And what if we wanted to say that this x minus 12 is being isolated? Well, we could write that into equations like this. So there's your first one. And you could do x minus 12 equals negative x plus 3. So then you solve again, you move this x over here, that'll get you your negative 12 equals 3. Doesn't make sense. Over here you have x minus 12 equals negative x minus 3. You move this over, you'll get 2x equals, move the 12 over here, positive 9. X equals 9/2. And that was our answer from doing it from the other side. Example 7. So here our absolute value expression is on the bottom. But just like before with regular equations, we can move this to the top by cross multiplying. So if we set this diagonal here, this product, equal to this diagonal, we can bring this expression to the top here. So let's do that. So 4 times x plus 1 equals negative 2 times absolute value of x minus 3. Now we just need to simplify. Let's distribute the 4. 4x plus 4 equals negative 2 times absolute value of x minus 3. And now all we need to do to isolate this absolute value is divide by this negative 2, both sides. And I want to clean this up a little bit. So if you recall, if we have a fraction and we're adding them and they have the same denominator, we can write this as 4x over negative 2 plus 4 over negative 2. And these negative 2's will cancel over here. So we're just left with absolute value of x minus 3. And we can simplify this one more time. So 4 divided by negative 2 is just negative 2x, right? Positive divided by a negative number gives you a negative number. And then plus a negative number, so that's just going to be minus 4 divided by 2 is 2. And that is still absolute value x minus 3. The other way to do it is you don't have to split it up like this if you recognize that this 4 and this 4 are both divisible by 2, and you go straight to your reduced version of that here. So at this point, we've isolated this absolute value. So we can make our two equations, but notice that this time it's on the right side now. Now it doesn't really matter, it's just kind of a preference, but I'll keep it on the right side to show you that we'll get to the same answer essentially. So my first equation, I'm going to write negative 2x minus 2 equals x minus 3. And then my second equation, it'll be the negative version of that. So negative 2x minus 2, and that equals x minus 3. So let's solve. I'm going to move all of my x's here to the left side. So if I move this x over, that'll be negative 3x. And I'm going to move this negative 2 over, so that'll be negative 1. And then I'll have an x equals negative 1 divided by negative 3 is positive 1/3. So that's a potential answer. Over here, I'm going to have to distribute this negative sign to simplify. So I'll just have 2x plus 2 equals x minus 3. Move the x to the left, so I get 1x equals negative 3 and then minus 2, so that's minus 5. So those are my two solutions, potentially. I will take the original equation now and plug them in to see what I get. So let's do 1/3 first. 4 over 1/3 minus. So another way to write 3 would be 9 over 3. And that's supposed to equal negative 2 over 1/3 plus, another way to write 1 is 3 over 3. And this one does not have an absolute value. So now we just kind of evaluate this. We'll have 4 over absolute value 1 minus 9, that's negative 8 over 3. And then on this side we have negative 2 over, that'll be 4 over 3. So essentially, we have 4 over 1 divided by the absolute value, so this will be positive 8 over 3. And that will be, I'm going to multiply the outer number, so that's 12 over the inner numbers. I'll reduce this by dividing both the top and the bottom by 4, and I'll get 3 over 2. Okay, and that's supposed to equal this negative 2 over 1 all over 4 over 3. And let's see. So I have negative 2 times 3 is 6 on the top, negative, and then a 4 on the bottom. If I reduce that, divide both top and bottom by 2, I get negative 3 over 2. So I have a negative 3 halves and a positive 3 halves. So this answer does not work, actually. So yeah, this is not a solution. How about the negative 5? We have to try that. So let's plug that one in. We have 4 over, negative 5 minus 3. That's supposed to equal negative 2 over negative 5 plus 1. And so we get 4 over absolute value of negative 8, right? Equals negative 2 over negative 4. Okay. I don't know where this came from. Let me take that out of here. So what we end up with here is 4 over absolute value of negative 8 is just positive 8. I reduce that, that's 1/2. And if I look at this side, divide both by negative 2, I'll get positive 1/2. So pretty messy, so I apologize for that, but we can say that this answer does check out. So we're left with one solution for this problem, x equals negative 5. Example 8. So if I look here, I notice I have 2 absolute value expressions. But if I look closely, I realize that inside the absolute value, they both have x plus 4. So what I can actually do is I can say I have 3 of these guys, and I have 2 of these guys over here. So they're like terms, which means I can subtract. And I can move this over to this side. So if I do that, I'll have 3 minus 2 of these guys, so I'll only have 1 x plus 4 on the left side here. And I want to move this 4 over to this side, so I'll have 6 minus 4 is 2. And then it becomes a much easier problem than we thought it was going to be. So x plus 4 equals 2, and x plus 4 is negative 2. We solve for these equations. I get x equals negative 2 and x equals negative 6. Let me plug that back in there. So I'll do the negative 2 first. 3 times negative 2 plus 4 equals 2, negative 2 plus 4 plus 6. That will be 3 times absolute value of 2 plus 4 equals 2, again absolute value of 2 plus 6. 3 times 2 is 6 plus 4, and then we have a 2 times absolute value of 2 is 4 plus 6, and they're both 10, so that number is good, or I should say that solution is good. If I plug in negative 6, that would give me 3, and I'm just gonna, instead of negative 2, I'm putting in a what was it, negative 6? Yeah. So negative 6 plus 4 is negative 2 plus 4, and then again 2 times, instead of negative 2, that's negative 6, so again that's negative 2 plus 6. Absolute value of negative 2 is just positive 2, so it's 3 times positive 2, 6 plus 4. Same thing over here, we'll have 2 times absolute value of negative 2, so that's positive 4, and again we get 10. So both of these answers, x equals negative 2 and x equals negative 6, are valid. Now that should cover most of the absolute value equations you're going to see. There are some more complicated versions of them, but I'm going to save those for the Algebra 2 section.